Hello, welcome everyone to question number 2, Heap sort. From the topic Heaps in Geek for Geeks must do coding interview question. Have a quick look at the question. We will be discussing the meaning and approach behind it. Before that, if you have any extra email IDs, please do subscribe our channel and support us. And if you have any doubt, just leave a comment down below. We'll be very quick to respond. Now coming to the meaning of the question, here an array has been given to us in this question. Now this question is saying we have to use a heap sort method to sort this array in ascending order. In ascending order means we need these elements like 1, 3, 4, 7 and 9. Okay, this should be our final output, but we have to use heap sort to get it. Okay, if you don't know what is a heap, I recommend you to watch some videos from max heap or min heap topic, and after that please come back to this video. It will be more clear. If I make any future videos for heaps data structure, I will be sharing the link on the above corner. Okay, now coming to this question, we are going to use the max heap method. Okay, I'm going to use max heap. Okay, and the process of this making this array to a max heap is known as heapify. Okay, now let us start converting to it max heap. But from which element should we start converting? Okay, we should always convert the elements from the middle index. Why? Because they, if you see the child nodes here, 1 2 3, okay, child nodes are always half. Okay, half elements are there. Child nodes, half elements are almost there in every tree data structure, right? In every tree we can see here, the child nodes are always half of those. Okay, in binary form. Now if these are half, then that means we don't have to check for a heap sort for 9 and 7 3. To check for single elements, there are no child nodes, so we cannot compare. So we can leave these child nodes alone, this 9, this 7, okay, and this 3. We can leave them alone in a way. So we will simply take the length of this array and we will divide it by 2. So length of this array is 5, and 5 by 2 we will get 2.5, but we want the lower function value, so we will get 2 as an answer for that. That means we have to start from index 2. From index 2 we will direct one index, we will reduce one index each time, and we will move towards the left side. Okay, according to this we have to start from index 2. This will be our index 2. Okay, I will be writing down indexes also. This will be 0 index, this will be 1, this will be 2, this will be 3, and this will be 4. Okay, now we have to start from this 3 node. It doesn't have any child node. Okay, so the elements will remain undisturbed, but there is a method to check. Now for that we have to take largest variable here. We take largest variable here, then we will get I as a value here. Okay, for largest we take I, and for left child, okay, we have to know the child exists or not also, right? So for that we will take left variable here, and we say 2 times of the index plus 1. Okay, 2 times of index plus 1 will get us a left child. If there is no index present, then means there is no child element. Similarly for right side, we use 2 into I plus 2. Okay, this will get us right child, and left one will left child. If no index is present, then that means the child nodes are not present. Okay, now starting from the 3 value, this is second index. Okay, now apply this formula. Largest index present at 3 here. Okay, first, sorry, index number is 2, value is 3. If you apply this formula, we get largest as second index. Now for left child, okay, for left child we have 2 into y, 2 into 2 is 4, 4 plus 1 is 5, 5 is the left child, and right child we have 6 as an answer. So 5 and 6 are both out of bound because the length of an array is 5, so it will only have up to 4 index, right? So this doesn't have any child node, so we can leave that as it is. Okay, and each time we have to reduce one index, and we have to heapify till there is no greater element below that index. Okay, now second index work is over. Now we will come to this first index here. Okay, at 1 here. Now same, apply the same formula. Now largest index is 1 present currently. We have to assume largest index as 1 for this node, and we will check to be sure if it is largest or not. Now again applying this formula, 2 into 1 is 2, 2 plus 1 is 3. Okay, this will be our left child, and right child 2 into 1 2, 2 plus 2 will be 4. Okay, this will be 3 4. Okay, and 3 4 indexes are present. Okay, 3 4 indexes are there. Now, if the elements are present, if child elements are present, now we will compare. What is the greater element in this? 9 greater than 1? Yes. Is 7 greater than 1? Yes. Now we compare this. What is the greatest from 9 and 7? 9 is the greatest element. That means 9 will be replaced with the parent node here. So that means the greatest element is this. So for this one index, okay, for this one index, largest index will be replaced with third index. Okay. After replacing, we will get the tree as 4, 9, 1 and 7. This will be 3. Okay. This is our second change diagram. Okay, next one. Now this is over and I have told largest index is 3 now. 3 index is present here. It will also check KP5 for the below elements also if it is present. As you can see, this is a child node, below elements are not there. If it is not there, then it will stop. But if there are any elements, it will heapify. Okay. Okay, now let's go to the next index here. Okay, that will be fourth element, 0th index. Okay, for this we have largest index as 0. Okay, now it is largest as 0. Now it will check this one. This is the change tree now, right? It will check is any largest element from left and right side. Yes, this is 1 and this is 2. We can also apply the formula. You will get the same index. 2 into 0 is 0. 0 plus 1 is 1. 1 and this will you will get 2. 1 and 2 indexes. 1, 2 is there. Now if we check 9 we have and 3 we have. Now we have to take the greatest element and exchange it with the parent node. Okay. Now greatest is 9 here. So we have to replace that with the parent node. Okay, let's draw the diagram. Now we got 9 here, 4, 3, 1 and 7. Now you can see the largest index is 1 in this case. So after replacing, largest index will become 1 now. Okay, for this one index also we will check again if there are any elements below which are greater than the parent. Okay, now you can see this is a parent node, and if you check left and right side elements, so right side child value has greater value than the parent node, so it will again exchange 9, 7, 1, 4 and 3. Okay, this will be our final answer. 9, 7, 3, 1, 4. So these are the elements which are perfectly represent the max heap. Okay, now if you change this into a array, we will get the elements as 9, 7, 3, 1 and 4. Okay, this is the max heap. Okay, remember this max heap. Now after getting this max heap, there is one more process that is called heap sort. Okay, and the heap sort, what we will be doing is we'll exchange the greatest element with the last element and we will use heapify. Okay, while we do this thing heapify, we will be getting the largest element on the right side and continuously we will get the smaller element to the left side. So in that we will get ascending order. Now let's discuss the heapify taking this 97314 for example. So if you see, this given array has been converted to a heapify format in the form of max heap. Okay, we converted into a max heap and this process is called heapify. After that, what we're going to do is we will exchange the top element with the last element and we will use heapify method there again after that, and we will not touch the last index at that time. Okay, after exchanging we will not touch the last index. We'll compare the remaining array and convert into a max heap format. Okay, now let's exchange the element and see what we will get. 4, 7, 3, 1 and 9 will be there here, but we will not use the ninth element. We will only consider up to this array part and we will use the heapify method here. The above method we used here heapify, that same method will be used again here heapify. Now after doing this we will get 7 at the top. Okay, I'm not using the diagrams here, so the actual data may be little bit different, but the max element will always come at the starting only. Okay, 7, 4, 3, 1. Okay, 9 is stored there. Okay, 9 is not being used. We will write 9 also, but this is not being used now. Now after heapifying, we got 7 at the starting position. Now again, now we will reduce one index. Previously we exchanged the last element. Now we are not using that. So the remaining array, the last element will be 1. Now just replace that with the starting again. We will get 1, 4, 3, 7, 9. Okay. Again, we won't be considering the last two elements. Now the starting three elements are there. we will use heapify on these three elements only. Okay, and we will repeat this process till we get, okay, till we get 1, 3, 4, 7, 9. Okay, till we get these elements, we will repeat this process, and this is known as heap sort. Okay, if we have understood the presentation, that is very good. If you haven't understood, let us go into the coding section. After seeing the coding section, it will be more clear what I have explained. Okay, now let's go into the code. Now we're inside the Geek for Geeks website here, and there are three functions that have been defined: heapify, another is build heap, and another is heap sort. And we'll be starting from the heap sort function. In this heap sort function, the starting it will call build heap function, and build heap will function call the heapify. But the build heap function will ensure from the middle index value, okay, from middle index value to the left side index of the array. So left side of the index array it will call from middle to the left side index array. So the starting element will be 2 here. 2 index I will be equal to 2. N will be 5. 5 divided by 2 will be 2 here. Okay. So that 2 index will be I here, and N will be the full length of the array. So in that way it will take largest as equal to I equal to 2, and left right child nodes will come as we have discussed in the presentation. Now left should be smaller than n and right should be smaller than n. This is ensuring so that it doesn't go out of the bounds. And another condition is array left should be greater than array largest. If it is, then largest index will be the left one. But if the right side child is greater than the current largest, then right side will be the largest one. Okay, so if left is largest, left will become largest. If right is largest, right will become largest. Okay, and after that we will check if largest is not equal to y. So if it doesn't have any child nodes, then largest won't be changed. Okay, suppose largest is not left and largest is also not right, that means largest is equal to I only. So there is no change, that means there is no child elements here. In that case this loop will not run. But if there is any child elements there, left and right, okay, then this loop will start here. Okay, and also if the child element exists and that should be greater than the parent node, only in that condition this if condition will be satisfied. After that we will exchange both of those elements, and we will call heapify function again for the largest index here. Okay, it will repeat again and again till there is no child nodes present, or you can say there is no largest element present after that. Now if the heapify function will always be recurring again and again. For second index or first index or zeroth index, it will call 3 times, and after calling 3 times, this function will occur 3 times in that. Okay. After this whole process has been completed, we would be successfully converting the elements into a max heap. After converting max heap, this for loop will be starting for I in range n minus 1. Okay. From the last index value. Now here we are going to swap the elements. Largest, the last value and the starting value will be swapped here. After swapping those elements, okay, now see carefully here, we are passing the zeroth index here, and I will be the last index. We are not giving the total length of the array. Okay, we are reducing one length. If you see the heapify function here in the build heap, we are giving n length here. We are giving n length is heapifying all the n index values here, but we are giving here one index, one length less here. One length less means one index less. Okay, so one element is left out from the right side, and all the remaining elements will be heapified. While doing this thing, we will get the last array as the ascending order. Okay, this is the code. I hope you have understood the presentation and also the explanation of this code. If you like the video, please give us a like, and if you have any doubt, just leave a comment down below. We'll be very quick to respond. Thank you for watching till the end. Let's meet in another question.